Okay, so follow along with the lecture here, and you should be able to see the quiz on there called Humans in the Biosphere, lecture number 2. We're going to talk today about the impact of humans in the biosphere, and you should be able to answer the questions as we go if you just kind of follow along. If you think about it though for a second, humans are a major part of our world, of our landscape, of nature. We have a decided impact on everything that's out there, right? We're really the first creatures to be able to have a global impact on everything. And as such, I think we have some responsibility, like, for dealing with that and for taking care of what we're doing. Okay, thanks. Okay, so as we go here, we're going to try and talk about that some. Let's take a moment here, and I want to consider an island, okay? Many environmentalists talk about how we need to think about the Earth as an island, but it's hard for us to do living here in central North America, here in Indiana. We're in the middle of a gigantic continent. You don't feel what it feels like to be on an island, to truly live on an island. I've been to a number of islands. I have been to this island right here. This is Rapa Nui, as the Easter Islanders call it, or Easter Island, as the rest of us call it. And it's small. Like, this is a tiny, tiny little island. It's 15 miles long, about 7.6 miles wide, at the widest part right here. It's not very big. In fact, if you're looking in the middle of the island there, I hiked up to the top of this volcano here, and I could see every side of the island. That's how small this is. Now, Easter Island is the most remote island inhabited by people in the entire world. So there's not another island in the planet that has people on it living there that's as far away from any other part of the world. Okay, guys, let's pull the masks up, please. There you go. Thank you. So, as humans, we rely on resources on Earth to survive, right? But for us here in the grain belt, resources are seemingly unlimited. Like, there's just so many resources. There's so much food, there's plenty of water, there's plenty of air. Everything we could ever want, we've pretty much got. We're sitting pretty here in America, especially where we live. Now, like other organisms, humans affect their environment, right? We do agriculture, we develop, we grow industrially, right? If you lived on an island, you would be acutely aware of how limited your resources are. And that exact thing happened to the Easter Islanders. So Easter Island is a long, long ways away from pretty much anything. Kind of show you where it's at here. Here it is on a Google map. Now, like I said, I've been to a number of islands in my life. Rapa Nui being the smallest one I've ever visited. I've spent a good deal of time in Iceland, and Iceland's kind of up here. There's Greenland. You can see the snow-covered part. Iceland is the greener part of our area up here. Greenland is fast melting right now. In Iceland was pretty surprising too, because you don't have the resources. In fact, all of their fresh fruits and vegetables they have to import from China. They don't come from Iceland. You don't just grow them there unless you have a greenhouse. They don't have big fields like we have. They do grow some sheep, right? But there's not a lot of grasses. Like there's not resources like we have here. It's really, really different. A friend of mine who was competing in the CrossFit Games a number of years back happened to be out in California, and she was in a supermarket, and the Iceland team, the Iceland people who were over to compete in the CrossFit Games, were up at the counter in the deli area, and she was right behind them in line, and they're tall, blonde-haired looking people. They're unmistakable, right? And plus these folks are famous in the CrossFit community, and she's standing behind them, and she hears them kind of whispering and talking kind of back and forth. They're like, "Gosh, can you believe can you believe how cheap it is? Oh my gosh, there's so much meat. Like, I'm gonna buy all of it." Right? But her having not been to Iceland, she didn't understand, like, if you wanted to go to a supermarket, of which there are not many in Iceland, and purchase, say, a pound of uh, bacon, I mean, 25, 30, $40 for a pound of bacon in Iceland. Like, you don't just eat bacon. You don't just wake up in the morning and go, gosh, a bacon, egg, and cheese sounds really good. You don't eat that unless you're really, really rich, because you can't grow it there. You can't create it there. It's got to be imported. All that stuff's really expensive. And so these folks are just kind of freaking out at this counter like, oh my gosh, look at all the food. There's so much. Oh my gosh. They just wanted to buy it all. They're like, we're going to eat all of it. It'd be amazing. So when you live on an island, you view things really, really differently. And Easter Island is sort of an infamous example of what can happen to your environment if you don't take care of it. Okay? It's a small place. Now, the people that landed there, the Polynesians, there was quite a bit of debate about how they got there. They actually built balsa wood rafts, and they rafted the ocean currents. The Polynesians, a tremendous seafaring group, they are able to kind of people all these small islands in here. It's hard to believe, but they followed ocean currents on boats all the way out here and just landed on this island. Look how far away that is. It is a long, long way away. It took me an entire day of flying in 3 different airplanes to get there. Yeah, it's a long ways away. They landed there, and they brought with them things. Of course, they usually, when they traveled, they brought chickens and whatever livestock they had. They brought plants and things because they knew they were going to land in a new place. However, this was so far away that all that stuff had died on their boat before they got there. So they had no livestock. They really didn't have much in the way of food. They were starving probably when they landed. And we know some of this from the oral traditions of Easter Island. But Easter Island was like a paradise. You know, a lot of these little islands out here in the Pacific are sort of little oases, little island paradises. And of course, they set to doing what they do. You know, they built, they constructed, they harvested coconuts, they fished, they did all the things that they were used to doing. And before very long, they started running out of resources. They started running low on resources. And one of the reasons that they started running low on resources was, as far as we know, they started building these things. So now you know what Easter Island is. Have you guys ever seen these statues before? These gigantic stone moai, or I think if I remember right, they call them. There's me and my lovely wife and my mom. She went with us out there. You can see in the background there one of the volcanic peaks right there. It's not a very big island. I mean, you can see the whole thing. The ocean's right to my back right here. So they started building these structures, and there's quite a bit of debate about how they built them and how they moved them. What we think is, in order to move those structures, they needed to cut down large quantities of trees and roll these things, because they carved these big giant statues out of rocks that were in this volcano back here in the far background. And to push that from there to there, like, you can't pick this up. It's humongous. It's one of those, you know, mysteries, like they do the great mysteries of the pyramids sort of thing, even though we've pretty much solved like how it was done. Archaeologists stood these back up, by the way. They had all been knocked down. But they pushed these out to the coast and stood them up, and erecting one of these as a great chieftain was kind of a big deal. So they wanted to make these things. Well, they continued cutting down their trees to the point where they literally cut down the last tree on the island. Like, can you imagine, like, living in an environment where erecting these statues is so important that you would cut down the last, you know, coconut tree, right? The very last one. Continued to fish. However, at some point, with no more wood, they could no longer make more boats, and they could no longer sail off coast to make to do fishing. Now, Easter Island, it's well known, there's no fish around the island. You have to get away from the island a little ways to actually catch anything. So there was very few. Yeah, there were no fish right by the island. So they've got no fish. They've obviously got no plants. And you're thinking, oh well, there had to be some seed bank left in the ground, right? Well, even though they didn't bring things like chickens, well, they did bring things along. Those had all died. something else had come with them on the boat. They had brought with them rats. Now, it pretty much happened at every island that they peopled along the way, they brought these rats to and infested it with rats. It's just like no getting rid of them, right? Well, the rats ate all the rest of the seeds, all the palm nuts and the seeds that they might have planted to grow things. And we know this from archaeological excavations. So there's no more seeds left on the island. There's no more trees left on the island. You can't get out to fish. So you turn to birds. Because this island had such a bird population, probably we think had the biggest seabird population maybe of anywhere in the world. Like so many seabirds. And in fact, they even had like a whole cult of seabird eggs and all kinds of religious stuff surrounding the birds. They ate every last bird. I kid you not, like there are hardly any birds on this island anymore. They ate every single last bird. So now you're starving, right? There are no large animals on Easter Island. Like there's no deer, there's no mammals there save the rats they brought over. What do you start eating after you've eaten all the fish, all the trees, all the birds? That's right. They turn to cannibalism. There's a long, dark history of cannibalism on Easter Island. And believe me, after being there, they don't want to talk about it. Like they really, like it's like one of those dark periods of time. You know, it's just something they're not proud of. They don't want to discuss it. Sort of like, you know, us and what we did to the Native Americans. We don't really talk about that. You won't find it probably in your history textbook about all the horrible atrocities that Europeans inflicted on the native peoples here when we came. Did you read about that in history class? No, why do you not read about that in history class? Because we write the history books. It's his story. It's about us, the conquerors, the victors, right? Not about the people that we displaced and, you know, gave smallpox blankets to and did like really horrible things to. So, yeah, this occurs, so the people are starving, so they turn to hunting. And I know for a fact that they're hunting each other. My wife, as we're walking up one of these mountains not very tall, these volcanoes, we get to near the top, and she reaches down and finds a spear point. I mean, this thing's like 6 inches long, this humongous obsidian spear point. And I look at her, I'm like, wow, you know, because we both know that wasn't used for hunting deer. There's no deer, right? That was used for hunting people. And they've got a long, long history of that. The Europeans, when they came back by and discovered Easter Island, I think they used to call it Bone Island for a while because of the fact that there were so many bones there. Like a lot of people did not survive. In fact, the population was down to like just a few hundred from like the thousands that were there originally when they first peopled it. So this is what happens to your island when you don't take care of your resources. For us here in the Midwest, it's really hard to wrap our heads around this. It's hard to wrap your mind around the fact that the Earth, our planet, is really like one big giant island. And if we don't take care of it, there's not going to be resources for future generations. It's really obvious when you live on a small place like Easter Island. The effects are pretty real. This is where they used to get their water from. So imagine a place where you live where the only fresh water, because you're surrounded by an ocean, is in the bottom of a caldera. This is a volcanic crater. There's water down there. You can see that. I took this picture. And this rim just goes all the way around. The ocean is just beyond it to the right over there. But this is the only fresh water, so a heck of a hike to get a drink, isn't it? Right? It's really, really pretty tough. It's an interesting place. So let's talk about humans. We talked about carrying capacity the other day. Okay. We're currently increasing pretty rapidly, right? Over 7 billion people right now. We've roughly altered about half of all the land that's not currently covered in ice and snow. We're currently altering all the stuff that is covered in ice and snow. Not because we live there, but because we've polluted, right? At the current rate, world population is going to hit 10 billion by about 2050. I think that number might have come down a little bit since I wrote this, but on your packet quiz there when you're doing it, the date is 2050. Okay. A big question scientists have asked, and there's some scientists who think that this may be the case, is 7 billion people the carrying capacity of our planet? Is that what it can support? Right? But remember, when we talk carrying capacity, first of all, we know what happens when you overshoot carrying capacity. If this is the case, we're already in big, big trouble, right? We know what happens when you overshoot. Population gets decimated by things like disease, warfare, lack of resources. Lots of things occur to a population that's overshot its carrying capacity. But the real question surrounding this, the confusion about what's the carrying capacity of humans on the planet, really boils down to this question right here, which is, what quality of life does everybody deserve? Does everybody deserve the same quality of life that you have here in America? Do they? I asked you guys this before. And I think everybody's okay with that. Like, I want the people of Easter Island to have the same quality of life that I have here. I want the people of Canada, of Europe, of Saudi Arabia to have the same quality of life that I've got here, right? Like, they should have water, clean air, right? Food, things like that, a house to live in. They should have those things. But here's the problem. There's only so much Earth to go around. And if you want to give those same resources to everybody in the entire planet right now, you need 3 Earths. Like, not that like we just need to give them a little more, but you literally need 3 planets worth of trees and water and everything else to give everybody what we have here, if they're going to consume at the same rate that we consume here. So the question, you kind of have to alter it in your head a little bit. Yeah, okay, maybe 7 billion, maybe 10 billion is the carrying capacity, but at what cost to the people who don't get what we have? So it becomes more of a question of, do we want to give up that extra car so that somebody somewhere else can have resources to live? And that's a tougher question to answer. It's super easy to sit here pretty and go, yeah, we've got everything we want, everybody else should have what they want too. Until it comes down to, are you willing to have less so that they can have as much? So as a lot of population scientists have discussed, you know, one solution to all of our ecological problems is less people. But how do you do that? You can't really do that humanely, right? There's no good way to do that. And nobody really wants to do that. So it's a tough question. And I don't have the answer, right? Remember we talked demographic transition some last time. That's one hope, right? But yeah, less population means less consumption. So let's talk about our resources some. There is a big difference between what we call renewable versus non-renewable resources. Okay? A renewable resource is a resource that you can get more of in human lifetimes. Okay? If the ecosystems are healthy, you'll get more in human lifetimes. Can anybody tell what this is a pile of right here? What's that? Looks like fish? It's not fish. It does. These are close. These are buffalo skulls. This is the American bison. This is in the 70s. That guy's holding one at the top there. You see the skull? They're huge. Anybody been out to Yellowstone and seen our buffalo? We have some buffalo farms in Indiana. It's really cool, isn't it? They're humongous. Oh my gosh, they're huge. So think about the amount of animals that had to die to make a pile of skulls this high. They used to take these and grind them up for fertilizer in the 70s. When they first built the railroad, people thought it was great fun to hop on board the railroad with their guns, drive out on the railroad, and they would hang the gun out the train off the back of the caboose and just blam, blam, and blow these things away as they went through. Right? Because it was just fun. There were so many of them, nobody thought you could kill all of them. And secondly, we did kind of want to wipe them out, because if you wipe out the buffalo, guess what? The Native Americans don't survive. And we wanted to colonize the West. So there was a push to get rid of the buffalo, because if you did that, you could get rid of the Native Americans, force them onto reservations, things like that, right? Because we wanted that land. I know you won't hear about this stuff in the history books because we wrote the history books. But ask a Native American, boy, they're well aware of it. Let me tell you what. So what are renewable resources? Well, the buffalo should be a renewable resource. As long as we don't just pillage it, we should get more in our lifetimes. Pine trees, we grow those up in Michigan. We don't really have pine tree farms in Indiana so much. Renewable resource, right? Maybe not in your lifetime, but in a few human lifetimes, you can grow a new tree big enough that we can use it. Drinking water, that should clean itself. Clean air, that should clean itself if the ecosystem's healthy. Fishing, right? We should have enough fish because they should keep making more. Right? Renewable things that we're using today like solar energy, wind energy, wave energy. biofuels, all those things are renewable resources. Got it? Everybody answer the question on their paper? Let's look at a non-renewable resource. Oh, there we go. Non-renewable resources are resources that we can't get in a reasonable amount of time. It's not that they don't renew, it's that they don't renew on any kind of timeline that matters to humans. Nobody's got 100,000 years, 1,000,000 years to wait for more oil. They just don't have that time that we don't care about. Like, that's too long of a time frame, right? So even though these things are natural, in many respects, they're not going to renew in an amount of time. Pretty much any fossil fuel that you talk about is a non-renewable resource. So coal, oil, natural gas, tens to millions of years to form. You may not realize this, but most of our coal and oil that we mine today, that we drill down and we slurp out of the ground, or we dig down, we dig out of the ground, that stuff formed like 200 million years ago, during a time when the continents were in really different locations, and there was a very specific type of fossil tree that grew and died in swamps that no longer cover our entire continents. So when those things died and fell in the swamps, they got buried, and then we got coal. Okay, we got oil. Little creatures that lived in the ocean died and settled to the bottom and made oil deposits in the oceans. Okay. Yes, some of that's still happening today, absolutely. But not at the rate that it happened hundreds of thousands of years ago, hundreds of millions of years ago. So those things are not renewable. And there's these rare earth elements too, like things like lanthanum, neodymium, things like gold. Right? Those are rare earth elements. We've only got so much of them. So once we mine them all up, it's difficult. Now, what are we doing now? We've got plans to go out to asteroids to mine asteroids for things like gold and silver and rare earth metals. That's one of the reasons that NASA, did you guys watch? NASA just landed on an asteroid. That was really cool. If you haven't seen that, you should watch that. It is really neat. The Japanese did it before us, unfortunately, but we did it. We landed on an asteroid. We collected a sample of stuff from the asteroid, and it's currently flying back to Earth. Now, they got so much that they're actually losing some of it. It was so successful. But the reason we want to know is first of all, we want to know how our solar system formed, and that will help us understand it. Okay? But we also want to know what's on there. Is there stuff that we can mine? And if there is, you better believe people like Elon Musk are going to be making missions out there to mine all that stuff, because it's worth a lot of money, because we only have so much here on Earth, right? They're not after coal and oil, right? They're talking about rare earth metals and things that they want to get off of those. So let's talk biodiversity. We mentioned this a little bit the other day. There's some different types of biodiversity. Try to get in the same spot here. So there's a question about this on your quiz. Really, you could just say biodiversity is the degree of variation of life, okay? But there's different ways to kind of put that in perspective. There's ecosystem diversity when we talk about a variety of habitats. Like, do you go out there and is there lakes and streams and rivers and fields and forests? That's diversity of an ecosystem. Species diversity, which is what we studied the other day down in the trees. We said, how diverse are the tree species down there? How many different kinds are there? How well spread out are they? How mixed are they? Genetic diversity is a new way of thinking about things. This is pretty new. In other words, you can think about how many different forms of genes are carried by a population. It's a totally new way of thinking about diversity. When you think about the human population, like, how diverse is it? You think about, sometimes you might think about things like height or skin color or whatever, right? Hair color, things like that. But those are all genes. That's DNA. Like, how much diversity exists in the human population? And I'll tell you right now, diversity is a very good thing for life. Whether it's ecosystem diversity or species diversity or genetic diversity, you need that. It's not good to have mating in a population where there's zero genetic diversity. We recognize this, right? Like, for brothers and sisters to mate, that's a real bad thing. You find that abhorrent, don't you? Like, it's like, ew, that's like gross. Well, the reason is it's really bad for the formation of the embryo, right? It's not good if your genes are all really similar. So the more mixed up your genes are, the better the population as a whole. So actually, we're up to about 1.8 million species that we've identified already on the planet. That's a lot of different species. Let's talk about why, though. And you guys mentioned some of this the other day. Some of you guys laid it out really well in your question. So all life on our planet is interdependent. Sometimes we forget this fact, but even down to the tiniest ant, it's intermixed, it's interwoven with all the other food webs, with all the other life on the planet. We're all intermixed. And when we do something to nature, a lot of the times we don't see the consequences. But right now there's a big push to eradicate mosquitoes. We've actually genetically modified mosquitoes so that when the new ones are born, they don't survive. Or in other words, they aren't even born at all. What will happen if we eradicate mosquitoes? I don't know, I say good riddance, but there will be unintended consequences, things we didn't ever even think of, guarantee you, because everything on our planet is interwoven, okay? We mentioned this the other day, but the more diverse an ecosystem is, the more stable it is. Diversity is a good thing. And here's a new one that you may not have considered, but biodiversity is the basis for most of our medicine. Check that out. That may be a new one on you. About 25% of all drugs that are made in the United States and Europe are derived from plants. Did you know that aspirin originally comes from the bark of the willow tree? Acetylsalicylic acid, that's where aspirin even gets its name from. Native Americans used to boil down willow bark and drink it. It tastes awful. Let me tell you what, it's the most bitter stuff you've ever had in your mouth. It's terrible, but it's good for a headache, right? In fact, most of our drugs many of them come from plants. Still to this day, it's the only way we can make them. Some of the compounds are so complex, the only way to get it is to use a plant to make it. Think about drugs like, say, cocaine, right? It comes from a plant. Plants make most of our medicines, many of the things that we rely on. So destroying the rainforests, there's a lot of reasons we shouldn't destroy the rainforest, right? But one that most folks don't consider is that there's all kinds of medicine down there. There's a genetic diversity that we don't see anywhere else on the planet. What if the cure for cancer is sitting down there on a tree in an ant in the rainforest somewhere? There's a movie made about that. It is entirely possible. It's not far-fetched at all. So let's talk about some environments that are very biodiverse. Okay. So like we said before, diversity is dependent on both the different kinds of species that live there, as well as how intermixed they are. And nowhere shows that as nicely as maybe a coral reef. Look at all the different fishes and corals and little invertebrates that are probably in there. Like that is just teeming with different types of life. So let me ask you this. Which of these two would be more diverse, a cornfield or a redwood forest? What do you think? It's pretty obvious, right? Yeah, I mean, we're in Indiana. We know about cornfields. There would not be much diversity in that cornfield compared to down in the tropics. In fact, the tropics are one of the greatest diverse areas of our entire planet. As you move towards the equator on the land, tropical regions have more diversity than anywhere else on the planet. Okay. What did I say here? 2/3 of all species that we know about on land are in the tropics. So jot that one down because you're going to need that for the test. Okay. 2/3 of all the species on Earth that are on land are down in the tropics. These are the most diverse land regions on our planet. Has anybody been to the tropics before? Been to like a jungle? It's cool. The mosquitoes are terrible. But wow, I mean, you look at this plant right here and you think, oh yeah, there's a tree. Look at the moss growing on the tree. In fact, there's ferns growing off of the moss on the tree. There's trees behind there. Think about all the different insects in here and all the interdependence that's going on down there in the tropics. It's a real unique environment. Another area that's super duper diverse is the coral reef environment. Coral reefs contain the greatest diversity of any environment. Even when you stack them up against the tropics, a coral reef is more diverse than the tropics. Well, they usually are down there in the tropics too, aren't they? As far as land-based biomes go. But the coral reefs are crazy diverse. All the diversity there. Let's talk extinction for a moment. Okay? Extinction is a totally natural process. It happens, it has happened through all of long geological history, geological time. A lot of the time, we don't recognize this, but when something goes extinct, it's never coming back. The genes that made it up are not going to reappear. Now, something might eventually come about that looks somewhat like it, but it's not going to be it. Right? Extinction is truly forever. The current rates of extinction are somewhere around 100 to 1,000 times the natural rate. So much so that paleontologists, geologists have coined the phrase the Anthropocene. In other words, they're saying we're in a new era of geological time. And it's the era of geological time where humans have started destroying the entire planet. Like, that's now in the textbooks, right? We call it the Anthropocene. Because the rates of extinction are just so great. Do you know how we mark the major geological time periods? We mark them out essentially based on major extinctions. A mass extinction, like the one that wiped out the dinos, that I know you've probably heard of, marks the end of, or marks the boundary of what we call the KT boundary, okay? The Cretaceous-Tertiary boundary between geological time periods. It's a big boundary in the rock record because all of a sudden these giant monsters are gone forever and you don't see another one anywhere in the rocks after that. And what we're saying is that there's an extinction event going on right now on our planet that a few million years from now, if there's anything left on the earth that's thinking and breathing, it's going to look back on and go, hey, that marks the extinction event that wiped out so much life on this planet, and it was caused by people. That's what the geologists are saying, right? So a lot of the time we kind of make jokes about things like the dinosaurs. We say, you know, well, like you might call somebody an old dinosaur, like basically meaning like, you know, they're a loser. They're like an older, like they're obsolete, right? They don't exist anymore. You got to rearrange your thinking. If you think geologically, right, dinosaurs survived 186 million years. 186 million years they survived on that planet. 300,000 years is all the longer anatomically modern humans have been around. Like, we're not even a drop in the bucket in terms of geological time when you look at the dinosaurs. The dinosaurs beat us out by a long shot. They've been on the planet, they were on the planet much, much longer. In fact, they do still kind of exist today. Do you know how the dinosaurs exist today? That's right, chickens. Birds are the last living descendants of the dinosaurs. In fact, when we go ahead and place them in systemics and try and place them on a tree, they fall into the clade Dinosauria. Any bird that you pick out is technically a dinosaur. Want to know how T-Rex moved? Think about a chicken, right? Think about that. It's pretty crazy. Do you know that T-Rex had feathers? Yeah, every picture you've ever seen of T-Rex, including that one, is more than likely utterly incorrect. Because now we know, at least the juveniles definitely had feathers. That's how closely related to birds they are. Birds are dinosaurs. Let's talk about some threats to biodiversity. The first one I want to mention is exotic species. An exotic species is a species that doesn't come from the area you find it in. And we have loads of them. We mentioned some of them in Australia the other day. Here in Indiana, we have one known as the emerald ash borer. Have you guys heard of emerald ash borers? Some of you guys have. Awesome. Yeah. So it's kind of a big deal. We were out there walking in the forest the other day. Well, what's left of the forest? One ash tree left, and it's about dead. And if you looked at some of the stumps, you'd find all these little worm trails in there. Those are the grubs. The emerald ash borer is non-native. Comes from Asia or something, I think. And it infects our ash trees. It lays its eggs on the ash trees. The beetles are beautiful. Oh my goodness, they're large, they're green like this, they're really pretty. They lay their eggs on the ash trees, and then the grubs, as they grow, they eat the inner cambium, the inner bark of the tree, all the way around till the tree's ringed, and the tree just dies and falls over. They're predicting in the next 50, 100 years or so, there won't be a single ash tree left in North America. They'll all be gone. And then what'll happen, right? Will the emerald ash borer go away? Or will it find another tree to eat? It's hard to say, right? But we're stuck with this thing now, and it's really difficult to get rid of these. Nobody's really sure how to deal with them. They're a real problem. But we are losing all of our ash trees, right? Invasive species are a serious problem, a real serious problem. Here's another one. Zebra mussels. Have you heard of zebra mussels? Anybody been down to Lake Monroe or any lake and you see a little sign that says, hey, watch out for unwanted hitchhikers? They're not talking about picking up a guy on the highway. What they're talking about is checking the bottom of your boat for these little buggers. They are destroying our water habitats. They're killing off all the native mussels. Things don't eat them, so they're reproducing like prolifically. They're a real problem. But they're kind of a mixed bag. It's kind of weird. So this happened. The zebra mussels are native to the Black and Caspian Seas. That's a long, long way away from us. What happened was boats that sail across the ocean, they end up in the St. Lawrence Seaway, and they come into the Great Lakes. Trace, you got to pull that thing up, please. They come into the Great Lakes, and think about this. What's going on with the boat? You got this big metal boat, and you're in the ocean. Does anybody know anything about like floating in the ocean as compared to floating on freshwater? Where do you float higher, in the ocean or on freshwater? In the ocean, right? The ocean is much more dense. So if you lay on your back in the ocean, like you float really, really well. I can even almost float in the ocean. In freshwater, I can hold my breath all the way. I sink to the very bottom, like just straight to the bottom. But in the ocean, I can lay back on my back. In the Great Salt Lake, like completely float right up out of the water because there's so much salt in that thing. So here's what happens. Ocean boats that are sailing through the ocean, they're too top heavy. They'll tip over. They'll just flip over. So they pump the hull of the boat full of water. In the olden days, they used to use rocks. They'd carry a bunch of rocks on board and fill up the bottom of the boat with rocks. Thank you. And so then they get to land someplace and they have to dump all the rocks out. Well, what they do is they pump water into the hull of the boat, the bilge pumps, and then they sail across the ocean. They get to America. They get into our Great Lakes. They go through the locks and get lifted up into Lake Michigan, Lake Superior, right, or they move into the lakes. And then as soon as they hit that fresh water, they've got to do something. Because in the fresh water, they're no longer floating too high, they're sinking. So they start immediately pumping all that ocean water that they pumped into their boat back out. Well, most of us didn't really think that a lot of those ocean creatures could survive in freshwater. Like usually you take a fish out of the ocean, you throw it in freshwater, and that thing's done for. Right? It's not going to survive. However, zebra mussels that happen to be inside those boats survive just fine. And probably this occurred somewhere around 1988. So we actually have a date even. We can figure this out. They've outcompeted our native mussels, destroyed harbors, boats, water treatment plants, clogging pipes. As a kid, I used to run around the shores of Lake Huron. Like I just run out there and play up in Michigan, had a great time. And I can remember just running willy-nilly out into the water, across the rocks, like barefoot out there. And the water was really dirty. It was very polluted. It was you couldn't see, if you're standing in a foot of water, no way could you see the bottom. Like it was really dirty stuff. After the zebra mussels moved in, the strangest thing happened. The zebra mussels, first of all, they clogged up almost every pipe going into the Great Lakes. Clogged it solid, costing us millions of dollars to try and get rid of these things. Some of the pipes they clogged were water uptake pipes, so people's water supply. Other pipes they clogged were illegal dumping pipes, toxic chemicals going into the lakes. So they actually kind of helped us out in a bizarre way. And on top of that, a mussel is a filter feeder. They cleaned the sediment and filtered the water in the Great Lakes. It's kind of a mixed bag. Well, they've destroyed the fish populations and the native mussel populations. At the same time, they've cleaned the water up. So that now, like, you look at that water, you go up there, and it's like just really clear, out a long ways. But no way would I just run out there barefoot, because these little buggers will just slice your feet to smithereens. They're pretty gnarly looking. Here's their spread. This was in 2000, so they've gone a lot further now. They're all throughout Indiana and different places. But, you know, it's just specific to the lake, so if we can stop their spread, it helps out a little bit. Where I was talking about right here was the shores of Lake Huron, which is like right there. There's Erie. It's totally covered up in those things, right? But you can see the St. Lawrence Seaway where they entered. See the little line right there? So looking at these things, look at how they just cover everything. Right? And they can survive for a long time out of water on your boat. They just close up. They hold the water inside. You drive from Lake Michigan, Lake Erie, down to Indiana. You don't clean your boat. You put it in the water. All of a sudden, you've completely ruined an entire lake. Okay? $500 million a year to fight these things is what the U.S. is currently spending. Why do we fight them? Well, it's less that we care about the environment and more that we need drinking water and a place to dump our waste. So they clog up all the pipes. Likely, we're not getting rid of these things. Like, there's just no way. They're likely to just become a part of our environment in much the same way as the dandelion has. You guys all know about the dandelion. Do you know the dandelion doesn't come from America? It's non-native. You'd no longer consider it invasive. It's what we would call naturalized. It's been here so long, it's now a natural part of our environment. And nobody's getting rid of it. Like, you can pull those things out all you want. They're coming back, right? So likely the same thing will happen with these things, right? They've caused some very bizarre things happening. Lots of weird stuff. You guys can take a look at that there. But they're interesting. They're an interesting thing that's happened. And it's something we're trying to prevent the complete destruction of our ecosystems with. Let's talk about the ozone, okay? So a lot of folks confuse this with climate change. This is not climate change. It's not that it doesn't have some role to play in that, but it's not the same thing. This is an entirely separate ecological problem that we have met and dealt with. And the reason I'm bringing it up is because the hole in the ozone layer is something that we have started to take care of. Like, all this doom and gloom I've been dropping on you, like, humans have actually figured some stuff out occasionally. We've done okay. So here's the thing. You might have heard of ozone as a bad thing, and you might have heard of ozone as a good thing. It's both. Ozone is 3 atoms of oxygen combined versus O2, which is the oxygen you breathe. You want oxygen, you don't want to breathe ozone. Ozone will destroy your lungs. So what can happen down here on the ground is companies that are polluting and in automobiles that are polluting can release large amounts of ozone, can release compounds that essentially can create ozone down here on the ground. And that ozone can destroy our lungs. So you'll see things like ozone warnings in California where they say don't breathe the air outside today, stay inside. There's high ozone levels, it's dangerous. It's much less frequent in Indiana, but we do occasionally have an ozone warning in Indiana where it's bad to be breathing a bunch of outdoor air because there's ozone in it. Now, up in the upper atmosphere, we need ozone. Ozone is the reason that we're not all dead. Ozone protects us from ultraviolet radiation. The ultraviolet radiation it protects us against is so powerful that it would irradiate our planet. Like, we would all die. Couldn't go outside at all. Right? We use radiation to kill bacteria and things like that. So ozone's very good up high. It's very, very bad down low. And the stuff down low doesn't just go back up high. Okay? Now, back in the 70s, scientists started looking at data for the first time with satellites in examining our ozone levels. And you can see here, this is the ozone distribution in Dobson units. You can actually see the hole forming from 79 up here to 2000. And you can see it kind of going a little bit smaller here in 2010. You see that? Now, don't think in your head that this is an actual hole. Okay, that no astronaut is going to fall through this thing. Okay, it's a missing area of gas that should be there. You can't see it with your naked eye. There's gases that are missing above our pole that should really be there that protect our planet. So How did this happen? Where did this come from? Well, uh, it actually came from humans using a compound known as a CFC, a chlorofluorocarbon. So these things were originally they're in air conditioners. They still are sometimes. They're in refrigerators. Have you guys heard, when you dispose of a refrigerator or an air conditioner, you have to call somebody, you're supposed to get it pumped and cleaned out before you dump it in the landfill. They won't let you take it to the dump. You got to pay a fee to have the coolant in it removed. Okay, it's the only way to get it safely put away. And the reason is we don't want the CFCs to be released into the air. So don't ever cut the line on your air compressor, on your air conditioner, and let that stuff go into the atmosphere, whether it's your vehicle or your house or whatever. Plus, it can be kind of dangerous because it destroys our ozone. Another place they used to use CFCs, chlorofluorocarbons, was in aerosol cans. If you bought a can of paint, back when I was a kid, if you bought a can of hairspray, do people even use hairspray anymore? Is that even a thing? I don't know. But if you bought that stuff, and back in the 80s, boy, girls had this hair that went up like a wave and just tipped forward. It took a whole can of hairspray to hold that stuff up for the day. It was huge hair. Pretty funny stuff. But we were releasing CFCs, which don't harm humans. You can breathe them, they won't hurt you. But when they get into the upper atmosphere, they wiped out the ozone. They destroyed the ozone. So what we did was we made legislation. We came up with what was known as the Montreal Protocol. All the countries got together, the big ones, got together and we said, hey guys, this is bad stuff. We're literally creating a hole which is going to let UV light in that's just going to burn us all to death. Let's fix this problem. Let's find something else to use. And we did. We found a different propellant for those cans and those things. We started limiting just releasing CFCs out of your AC. And lo and behold, it's taken some time, but CFCs are going back down. Okay, so they're saying that maybe somewhere between 2060 to 2080, we will have taken care of the hole in the ozone layer. This is an environmental success story. Soak it up because there's not many. How do we do it? We worked together as a world community and we said, this is what we need to do. Let's create some legislation and let's fix it. And we did. Now, why can't we do that with other stuff? I don't know. I wish I could figure out how to make the world of human population all work together and agree on what would be best for all of us. But we haven't been able to pull it off. Let's talk about some other issues we've got going on. North Atlantic cod fisheries. So starting in the 50s, we developed some new stuff. We developed better boats and high-tech equipment known as sonar. Anybody ever use sonar to go fishing before? Fish finder? Yeah, right? It works really well. You can go out there and see where the fish are. Well, imagine large-scale commercial fishing suddenly gaining access to sonar. Suddenly being able to put that on their big boats, go out there with their giant nets, see the fish by the thousands and thousands, drop the nets in and just scoop them all out. Way more efficient than just taking a guess, right? So you can see when we first start to develop this, how many fish we start taking out of the water. This is blue graph right here, okay? Look where it shoots up. Suddenly sonar and better boats, we fish so much that we wipe out essentially all the fish. So the cod in 1992, they hardly took any out of the water at all because they had completely decimated the population. Right back to the buffalo, right? We're just we can take them all, so why don't we take them all? Well, there's a problem with this. How do we fix this problem? It's easy, right? Don't take as many fish out. It's so simple, it's stupid. The problem is that while, say, the US might agree, let's not take so many fish out, let's reduce the number of fish we're catching, okay? Other countries might be like, hey, we're not doing that. We need these fish. Well, the fish can go where the fish want to go. We can't control where the fish go. And so if other countries are still taking them out and we can't make an agreement like we did with the Montreal Protocol, we got problems. And then what happens to our fishermen? Our fishermen are standing there on the shores going, hey, Japan's getting theirs, Russia's getting theirs. Well, you don't care about me? You're not going to let me go fish? They're taking all the fish. And then what do? We go, oh, well, maybe we'll just, go ahead and take ours too. And we'll just take them until all the fish are gone. So it's the lack of the ability as a world to recognize that we're on an island. Like, this planet is our island, and what was one country does, the other countries have to deal with. Like, some way to work together is the only way we fix a problem like this. Now let's talk about the big one. Okay, this is a big deal right now. You hear about it a whole bunch. We are literally watching the Greenland ice sheet retreat day by day. Like, every day there's a new article in a new scientific journal talking about how fast this stuff is retreating. We're now watching the ice up above Russia, in that region up there in Siberia, disappearing so fast that it's uncovering vast reserves of methane that are buried under the ice and have been so forever. Methane, by the way, is a bigger greenhouse gas than CO2. Methane is so powerful of a greenhouse gas that once we start releasing that stuff out of the ground, there may be no turning back. Like, we're heating this planet up a whole bunch. So, what is this stuff? Well, first of all, we've got to recognize that there's a problem. And a lot of folks are still struggling with basic acceptance of science. We have a problem with understanding how masks work. We have a problem with understanding that the Earth is not flat. I know it seems silly, but there's an entire society on the internet devoted to, they're known as the Flat Earth Society. You could look them up, you probably shouldn't. They don't need your traffic. But they try to show that the Earth is flat. Now, how much more evidence do you need, right? We got guys up and girls up in a space station orbiting our planet around in a circle, ellipse actually, taking photographs of the planet. Like, how much more evidence do you need that the Earth is not flat? Yet there's still a whole bunch of people that think the Earth is flat. There's still a whole bunch of people that think that because they can smell a fart through a mask, that viruses can go through a mask, right? Like I don't know what to do with some of this stuff, guys. But global warming is absolutely happening, and we need to recognize this is a problem before it's too big of a problem. What does this mean? It means that average global temperatures are increasing. Okay? It means that sea ice is melting. It means that ocean levels are rising. If you melt ice, it goes somewhere, right? Especially if it's land-based ice. It goes into the water and the water levels go up. You don't need like a degree in any sort of science to understand that if you put more water in a bucket, like, the level goes up, right? So lots of species are actually responding to this. We see this right here in Indiana. Do you know that we've had instances of things like armadillos now in southern Indiana? What? Like, you drive down to Florida, you see armadillos, right? The things are migrating north because of the fact that it's warmer up here than it used to be. Has anybody noticed all the ticks we've had lately? The last like 4 years? These little things you guys call turkey mites, which are really actually Lone Star tick nymphs, the little tiny baby Lone Star ticks. They itch like mad when they get on. You can't even see them. We never used to have those like that. They're up here like crazy. Why? Because the temperature is changing. Things are migrating. Things are moving in response to it, and we can easily measure that stuff. So I want to show you a picture here, and you can kind of see it in the background there. I might have mentioned this before, but I've been to Iceland. One of the things that I did when I was in Iceland, what I really wanted to do, was to actually get on a real glacier. Now, there's my wife there in blue in front there. This is a glacier, the biggest one in Iceland, and looking out that way is towards the ocean, actually. We hiked up here on this glacier with this group of people, and I tell you this because it's kind of interesting, sort of like the conceptions of America and of us as a country when you travel to other countries. You guys are young still. You probably haven't been to another country. Maybe some of you guys have. But if you go to another country and you don't go to a resort and you meet people from that country and you get to talking to them, you find out that, first of all, the rest of the world has very strong opinions of us. Like, I bet you don't have much of an opinion of Ireland. You probably don't really care. You have an opinion of New Zealand, probably don't really care, right? Easter Island, I bet you've never even thought about that before. Like, oh, those Easter Island people are just dumb. I don't like them at all. You probably never even thought about it before. We are such a world power that everything we do the rest of the world sits on pins and needles and watches. I remember traveling around Ireland and being in some of these small little pubs and eating and talking to some of the locals. They knew everything about our politics. They could tell you which politicians they liked, which ones they didn't like. They would talk about people in our government I'd never even heard of. I was like, I lived there and I was embarrassed because I was like, I don't even know what you're talking about. I didn't even know that was a thing. They knew all about it. So it's very eye-opening when you travel to other countries. And this experience on this glacier was pretty eye-opening for me because we were walking down and you can kind of see where it's dry over here, there's no ice. And walking up to this glacier, and travel on a glacier is really dangerous. Like, these are crevasses here. If you fall down into one of these cracks, they can be hundreds of feet deep and they narrow. They go from really wide, like you see there, to narrower and narrower and narrower, to where if you slid down into that, you would become wedged and all your bones would be broken. Like, they can't get down to you to pull you out. That's why you see us using ropes and climbing gear and things like that and having crampons on our feet. See the spikes coming off those feet down there? Anyway, this small group of people, we hired this guide, this guy back here who's got all the ropes, to take us out here. And we're walking down here, we're walking up to the glacier. And this girl here and her boyfriend, who's in the back there, were from, where were they from? They were from South Korea. And this girl over here was from Germany. And I forget where this guy was from. But none of these folks here were from Iceland. They were from all sorts of different countries. And I'm used to meeting folks from a lot of different countries when I travel. And the guide wasn't even from Iceland. He actually he might have been from New Zealand, actually. But he had been on glaciers all around the world, right? So we're walking down, and I'm chatting with him. I'm like, how long have you been working here? He's like, oh, I've been here, 10 years. I've been on this glacier for 10 years, back and forth. I'm like, so have you noticed changes on the glacier? Like, do you see a difference? And he said, oh, boy, gosh, yes, right? He goes, and he points out over the horizon. He goes, see that little hill over there? That little hill used to be the foot of the glacier. And he points out to the one behind it. He goes, see that one back there? 2 years ago, that was the foot of the glacier. And he points out behind that one, he goes, a couple years before that, that was the foot of the glacier. And he could just keep going like that. And I'm thinking, my gosh, it's so hard to explain this stuff to folks in Indiana. Like, if you live in Iceland and you look behind your house, and every year you look behind your house, you see that giant ice sheet further away from you than the year before, like, you recognize, like, people don't debate climate change in Iceland. Like, people would laugh at you. So look behind your house. Like, look at that big glacier. It's no longer there, right? It's going away. They're very aware of it. And so we're walking down this thing, and I'm trying to chat with him. He finds out that I'm an educator, and he goes to me. He says, I tell you, kind of wanted to ask me a question. He's like kind of hemming and hawing about it. And he goes, so what's wrong with you Americans anyway? I'm like, what? Excuse me? What's wrong with us Americans? He says, yeah. He says, don't you guys like actually teach how to read graphs in school? Like, how do you not accept science? Like, it's so simple. He's like, do you not teach graphs? I'm like, oh boy, really I try really hard to teach how to understand a graph and read a graph. And, he was really giving me a hard time because of the anti-science sentiment that sometimes circulates around our country. And I don't understand it because I try really hard to explain this stuff. And what's funny is not funny, the two other Koreans over here, they jump in on it too. So it's like everybody attack the Americans kind of time, right? And then she says, hey, is it safe in America? I'm like, is it safe in America? And she goes, yeah, is it safe in America? She says, can you go out and do things, or is it not safe? I'm like confused now because I'm like, of course it's safe in America. Like, why would it not be safe in America? And she says, well, do you feel safe like going to the movies, in like the movie theater? And she was like honestly asking me this question, and then it hit me. I don't know if you guys remember back a number of years, but that guy was shot in the movie theater. Like, somebody was arguing with somebody behind him about being too loud or something, and the guy stood up and shot him with a gun. And so what she was saying was, everybody in America's got a gun. Is it safe? Like, can you walk around on the street, or do you have to worry about somebody shooting you? And so I'm like, oh my gosh, this is like what the rest of the world, like, this is what they think about when they think about America. I'm like, no, it's not like that at all. It's totally safe. I don't have any trouble going to the movie theater or anything like that. I'm trying to explain this to her. All the meantime, in her mind, she has this visual of America as like the wild, wild west. Like two guys getting into an argument, they walk out in the middle of the street, they pull out their, the 6-shooters and blam, 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 blow each other away. Like that was like her visual of America. Like, my gosh, we need to change this. But it's eye-opening to see yourself through the lens of the rest of the world. It really, truly is. But yeah, they really didn't understand why we couldn't accept climate science. And so anyway, I told these guys, so like, you know what, I'll try even harder. I'll get some graphs out. We'll try and talk about this stuff. So let's look at some graphs here, just for the sake of the folks I met there in Iceland. Here is, if we look at temperature anomalies, this is the change in average temperature over land and over ocean. What's happening to temperature as you go across this graph to the right? You notice how it's going up? Average temperatures on land and in water are increasing. This is not really arguable, guys. This is just data. You drop the thermometer in the water, you put the thermometer on land, you record the temperature. Every year you do the same thing. If the graph looks like this, temperature is increasing. Cool? Let's take a look at this. Let's look at sea ice. If we measure how thick the sea ice is using sonar and other like methods, year after year after year, and we haven't started this from very long ago, what's happening to sea ice? It's definitely disappearing, right? It's going to be gone probably in your lifetime. Sea ice, not land ice. Now let's look at this one here. Well, this is a little bit more stark. Look at the drop in sea ice here on this graph. It's a little further out, right? How about sea levels? What are those doing? Increasing, right? It's pretty obvious. Now, let's talk about why and what's going on here. So, it's confusing to talk about climate change for some of us because, well, you lived through it. You lived through the start of our understanding of it, you lived through our scientific comprehension of it, and you've lived through like our trying to explain this to everybody. It's just like any other scientific discovery or understanding. It takes time to get people to understand it and accept the results of it, okay? And people grasp at straws. In the beginning, when scientists first started raising the alarm on this, people said things like, well, what is it, a natural cycle? Is this just normal, right? Is it really caused by human activity? Is there some geological change? Is the sun heating up? Are we getting closer to the sun? Is there some other reason? And yes, scientists looked at all those other possibilities. We looked at all of them. They've all been ruled out, right? We understand that this is caused by humans now. Like there's no doubt about it. Over the last 200 years, carbon dioxide and other greenhouse gases have gone up dramatically. We know for a fact humans make CO2 and other greenhouse gases. We've been spewing them out since the Industrial Revolution. We can measure that stuff. Those things strengthen what's already a natural greenhouse effect. If the greenhouse effect didn't exist, if things like CO2 didn't warm our planet, we'd all freeze to death. We need some. We can't just have none of it. The problem is we have too much. So when we look at these graphs, there's me on an iceberg. How about that? Float out to sea, right? My hiking boots. The water is really cold, by the way. If we look at this on a graph, guys, it's obvious. Look at this. CO2, nitrous oxide, methane. What have they done? That's exponential growth right there, right? If we look at our models for this, we see things like we could possibly see warming anywhere from 2 to 10 degrees Fahrenheit by the end of the century. That's a problem, right? Some things are going to be really threatened, like coral reefs. We know that they're in trouble. Some things are going to get drier, some will get greener, some will get more flooded. It's really hard to predict exactly how this is going to affect things. All we can really say is that things are going to be different. Probably not for the better. Oh, come on. That's a moulin, by the way, that big hole. Water's going down that all the way to the base of the glacier. It's pretty cool. So it's a real serious problem. It's something we need to consider as a whole world. Okay, should be able to finish answering your questions. There we go.